Hello, everybody. So what we're going to be looking at today is section 3.7 in your book, which is inverse functions. And this is going to be part one of a two-part lecture on this topic. We're not going to cover everything in this one video. Okay. What we are going to cover in this video is pretty much going to be like the easier type of problems with not too much algebra yet. Okay. And some of the definitions that you don't really need to use very much. So yeah, so where we'll start is just by reminding you in 3.4 we had composition of functions, compositions. And compositions were when you calculated something like f of g of x or g of f of x, right? So you know how to calculate those, and yeah, you know how to calculate those. So the definition of inverse functions actually involves composition of functions. So here it is. So two functions, f and g, are inverses if f of g of x is x and g of f of x is x. Okay. You have to use, well, no, you don't actually have to use these. I was going to say you have to use these formulas to find an inverse, but that's not actually true. You can use these formulas to check if two functions are inverses, but you don't use them to actually find an inverse. I don't want to just leave it at that, so I'm going to scroll down here and I'm going to see if I can. Maybe show that a function is an inverse of another function, which you're not going to have to do, I think, in the homework, but maybe I'll just show you it anyway. So let's just do an example down here. So let's say I give you two functions, and I'll ask, are the functions, let's see, f of x equals, let's say 4x plus 3, and g of x, have to think about this for a second. So yeah, let me think about it. So let's say, actually, let me go here. I'm going to change that. Let's put a 2 there. It'll be easier. Now let's say, let me think. So complicated. So let's go 1/4 x plus minus 1/8 inverses of each other. Now I'll tell you that what I was trying to do, I was intending for these two to be inverses of each other, but if they're not, then they're not, right? Like we'll have to check using the definition. So let's just mention how to do that, and we might do this more in the next lecture, but I just wanted to do this at least just to give you a feel for the definition, even though we're not using it much right now. Okay, so according to the definition, f of g of x is supposed to be x, and g of f of x is supposed to be x if they're inverses. So if they are inverses, then f of g of x is x and g of f of x is x. So what you have to do is actually check both of those. So we need to check both of those properties. So we need to check them. So how would we do that? Well, we know how to check, we know how to evaluate what f of g of x is, right? Because we did that in the previous section. So let's start with this one, f of g of x. So I know that the way to calculate f of g of x is to write what f of x is to start with. So f of x is, according to this, 4x plus 2. I'm just reading the formula, right? And we know that that means that f of g is 4g plus 2. And then if you take this g, so you take this formula for g, and we're going to plug it right there for that g and see what we get. So what we do get is 4g, but g is 1/4 x minus 1/8, and then plus 2. So this is what f of g is. And then you work this out. So you would have to distribute that 4. So like 4 times 1/4 times x plus, nope, minus 4 times 1/8, that's times, plus 2. And then here you have 4 times 1/4, which is 1. So this is 1x minus, okay, see, I already know that it's not going to work out. So minus 4 times 1/8, 4 over 8 is a half. So this is 1/2 plus 2. So this is x, actually minus 1/2 plus 2 is going to be, if you add it, minus 1/2 plus 2 is 3/2. Great, so this is what f of g of x is. So I was trying to make it just x, but I didn't. I ended up with x plus 3/2, right? So f of g of x is x plus 3/2. It is not x. So since this is not x, we know that the f and g can't be inverses. So we got this, since this is not x, we can say for sure f and g are not inverses. Okay, so we don't need to go any further because we already checked what we needed to check. But if this did come up to be x, you would still have to calculate this one, g of f, which you would do the same way. So you would say like g of x is, wherever it is, 1/4 x minus 1/8. So g of f is 1/4 f minus 1/8. And if you fill in what f is 4x plus 2, 4x plus 2 minus 1/8. You end up with, what do you end up with? X plus a half minus 1/8. And it doesn't matter what this is. The point is that it's not x, right? So this is g of f here. So g of f is also not x. So again, we know that g and f are not inverses. Okay, so in order to be inverses, both of these, this one and this one, would have had to be x. Okay, so these functions were not inverses, and it's because I was trying to do the numbers in my head and it did not succeed. I think this would have had to be in like 1/2, I think is what it would have had to have been. But whatever. I'm not going to do more of that now because we are going to be using this definition in a little bit. So for now, this is fine. I just wanted to do something with the definition first off before we do numbers. So let's go back up here and look at this again. So this is the definition. If this happens, then f and g are inverses. And if they are inverses, then we give it a name. So typically, so you have f of x and its inverse, if it has one, and we'll use this symbol for an inverse. So it looks like a -1 exponent, f to the -1, but it is not. This is not an exponent. This is just a notation that means inverse. It looks exactly like an exponent though. Okay, so f inverse. F inverse. Okay. Now, how are we going to do calculations? Well, we need to know something about how these functions work. And so the way they work is as follows. So if you've got a table of values, like this table of values, right? So just look at this, x and f of x. So I don't have an f inverse column here or an f inverse row. I just have x and f of x. Okay, now we know how to calculate something like f of 3. If you were going to calculate f of 3, what you would do is you would go to the x column. So this 3, you know, is an x value, x equals 3. So you go over to the 3, and then you go down to the f of x value, and that's -2. So f of 3 is -2. Now you can calculate f inverse values with this same table. We don't need a table for f inverse. We can make one, but we don't need one. The way you would calculate an inverse value from the table is that the value in here is a y value or an f of x value instead of an x value. So this 3 is an x. This -2 is an f of x. So this -2 is a y or f of x value, just depending on how this row is labeled. But what you're going to do is basically look up the values backwards. So what you would do to calculate a f inverse of -2 is you look for a -2 in the y values, and then you come up here and get the x value. Okay, so what I'm saying is, let me erase these. Whenever you're working out an f of x or an f inverse of x value, then what you're doing basically is one of these numbers is an x and one of them is a y, or one of them is an x and one of them is an f of x. So this is the x and this is the f of x, right? But when you do an inverse function, it's the opposite. So this is the f of x value and this is the x value. So for inverses, you're basically just switching which row you're looking in, okay? And the reason for that, let's see if I say it here, that third bullet point, this is how inverse functions works. It works like this. I'll explain that again. Because f and f inverse are the same function, but with all the x and y values switched, okay? They're the same function, but the x and the y values are switched, okay? And that's how you find an inverse, is by switching the x's and the y's. All right, so just to summarize, we'll look at these bullet points. So if you wanted to find f of a, like this, f of 3, you look up a in the x column, right? So like for f of 3, you look up 3 in the x column, and then read off the number from the y column. So you go to here, and then you go down to the -2. And like I say, you've done many times before you get to here. To find an inverse value, you look up the number in the y column. So you're looking up for f inverse of -2, you look up -2 in this row. And then you read the number off, you read the x value, and that's your answer. That's what's new in this section. Okay, and the reason it works this way is, like I say, it's because f and f inverse are the same functions, but with the x and the y values switched. Okay. So let's just see if we can make sense of this. Let's just do it again. So how do we calculate f of 5? Well, remember the 5 is an x value. So you come over here to x equals 5, and then you want this value. So that would be -7. Okay. Now, if you're trying to calculate f inverse of -9, this value is an f of x value. So you go to the f of x column row. I keep saying column because normally we have them written this way. But obviously this one's rows, not columns. So the -9 is an f of x value. So you go to the f of x row and you go over until you see a -9, which is right there, and then you come up and then that's your value. So the answer is 6. So do you see how they're just the same thing, but which row you're looking in? Okay, so that's how you find requested values of function values or inverse function values using a table. Okay. Now the thing is that if you can do this with a table, then you can do the same exact thing with a graph, right? So if I ask you to find f of 8, you would know that because this is f of 8, that this 8 is an x value, and that your answer would be a y value. So you come to the function and you're looking for x equals 8. So you look at the points on the graph and you say, where is x equals 8? X equals 8 is over here. So this is the point, 8, 2. So this is the x, so this would be the y, so the answer would be 2. Easy as that. Now, if we're doing an inverse, f inverse of 2, you would know that the 2 is a y value, and your answer would be the x value. So you would be looking for y equals 2. So y equals 2 is here. So you're looking for where the y value is 2. Of course, it's the same point. So f inverse of 2 is actually 8. So these are the same pieces of information, actually. When you say f of 8 equals 2, it means the same thing as f inverse of 2 is 8. It's still the 8 and the 2 that go together, right? X equals 8, y equals 2. X equals 8, y equals 2. Okay, so let's do these, the remaining problems here. So for this next one, f inverse of -1, so you know that the -1 is a y value because we're doing an inverse. Inverse means we're looking for the y value. So the y value is -1. So look here, where is the y value -1? And you'll find it here, right? -1, -1. So the y value is -1. And what is the x value? Also -1. Oh, that's the x value. Okay, so that one's done. And then we have f of 1. So this is an f. Because it's an f, we know that that's an x value there. So we're looking for x equals 1. You find the point here. That's where the x value is 1. And then what is the y value? Also 1. So f of 1 is 1. And that's how you do these with a graph. It's not super complicated. Okay, it's just you're looking, either they give you the y and you're looking for x, or they give you the x and you're looking for y. Okay, so actually, you know what? Let me switch to a worksheet. This is going to take a second. Sorry. So let me go to back this up. This is where I type your notes. Let me find the worksheet that I used for this class. That. All right. So let's look at this. Can I write on it? No, I cannot. Let me figure out what to do here. Let's just send that to Notability. Create new note. Import. Done. All right. So here we go. So this looks pretty similar, but this is actually a different, a slightly different document. Let's let's go down here. Actually, yeah. So this is, let's just do what we just did, but for a different graph here. So just to remind ourselves if we can do this. Also, I remember there's a typo on here. So this needs to be 3. Okay. So if we're going to find some f and f inverse values from this graph, again, you just have to remember x's and y's, right? So to find f of 3, we know that the 3 is an x because it's f. So what would the y value be? Well, look for x equals 3. So I look here, I find 3, 8 is on the graph. So what's f of 3? It is 8. 3 and 8. Okay, next one. F inverse of 4. So since this is f inverse, I know that the 4 is a y value, and I'm looking for the x value. So you look for where the y value is 4. It seems to be right here, right? 2, 4. And if the y value is what we were looking up, the x value will be the answer. So this will be a 2. This one, f of -3, this is f. So since this is f, this is an x. X is -3. So you're looking for x equals -3. You'll find it right here. Find it right here. So this did say -2, right? And if you look, I didn't actually, I forgot to label that point. So that's why I just changed that. So f of -3, x is -3. There it is. The y value will be the answer. So 0.0125. 0.125, not 0.0125. Okay. And finally, f inverse of 0.125. Well, this is a y value. So the answer is the x value. So when the y value is 0.125, what's the x? Well, right here, right? The y value is 0.125, x is -3. So these two are just the same problem, right? Just rephrased. This one's f of -3, and this is f inverse of 0.125. Okay. So of course, once you work those out, right, like I keep writing x and y everywhere, but this is all you need to write. You just need to know that you're looking for the x or for the y. Okay. So another thing here is just a property of inverses. So by definition, we said this, f of g of x equals x if they're inverses, right? But if they're inverses, we normally don't call it g, we normally call it f inverse. So the property is this. And also for inverse functions, the property is f inverse of f of x is x. Now, the thing is that property, I mean, that definition of inverse works no matter what the x is. Okay, so what you want to think of is this. You want to think of inverses as canceling out the function. So like f of f inverse, cancel and just leave you with the x. And then here, f inverse of f, cancel and just leave you with the x. Okay, and that's true no matter what the number is. So it doesn't matter what the function is. If I say, what is f of f inverse of, like, I don't know, 13? Like, what is f of f inverse of 13? You just automatically go, well, those cancel, and the answer is 13, right? So there's no thinking. When you see f of f inverse, you don't have to think at all, okay? You just cancel, that number's the answer. And that's what's going on here. At least it would if I had not so many typos. So like here, this one says f of f inverse of 6. And you should just go, what is that? Well, f of f inverse of 6 is obviously going to be 6. Okay. This one's completely written wrong, but it was supposed to be f inverse of f of 3 is what it was supposed to say. And if it did, what would the answer be there? Well, cancel, cancel, and the answer would be 3. Last one, f of f inverse of 1/7. Cancel, cancel. What's the answer? 1/7. Now notice we do not need to know what f is, right? We don't know or care what f is. We don't need to know. Okay, we don't need to know. We just need to know that if f and f inverse exist, they cancel each other out the way that we showed. Okay, so the next thing to do is to be able to do some basic calculations involving inverses before we talk about how to find an actual inverse function. Okay, and again, it always comes down to x values and y values. So on a problem like this, where I say let f of x equal 3x plus 5, and I say find f of 4 and find f inverse of 23, these are different problems, by the way. Like, they're unrelated. I just put them together. Just what are we looking for, an x value or a y value? And what are you given, an x value or a y value? So like, let's do this one first, f of 4. So to compute f of 4, of course, you know that the 4 is an x, right? X equals 4. Which makes this very easy because here's your f, right? So let me just erase this, actually. We don't need it. If f of x is 3x plus 5, then what is f of 4? Well, you put a 4 in for x. So 3 times 4 plus 5. And then you work that out. So 3 times 4 is 12. 12 plus 5 is 17. There's your answer. F of 4 is 17. Okay? Now, the completely separate problem is f inverse of 23. And the key here is remembering how we did that table, right? This is an x. The 4 is an x. The 23 is not an x. Because this is f inverse of 23, this is either a y value or an f of x value, depending on how you want to think of it. Okay. So when you write out the function again, so I'll start the same way. I'll write f of x equals 3x plus 5. You don't put 23 in for x. You put 23 in for f of x, which means it looks like this. 23 replaces the f of x. So you see the difference, right? Here you were putting the 4 in for x. Here you put the 23 in for f of x. And the x just stays x. Of course, this is not the answer. The answer is going to be whatever the x value is, remember? Because remember how it looked like this when we were doing problems? Like f inverse of, let's say a equals b. I'm just putting symbols in. Remember that this was a y, f of x value, and this is the x value that goes with it, right? It's always an x and a y. So if this is the y value, 23, we need to find the x value. That means you have to do a little bit of algebra here. So you have to do a little bit of algebra and solve for x. Now, how much algebra? Well, it depends on the problem, right? We got 23 equals 3x plus 5. So to solve this, you would subtract 5 from both sides. If you do that, you're going to end up with 23 minus 5 is 18. So 18 equals 3x. And then you would divide by 3. And you would end up with x equals 6, right? And so what does that mean? It means this. It means that f inverse of 23 equals 6. Again, this was an f of x or y value. And this is the x value that goes with it. So when we found x equals 6, we were really finding what we wanted. Okay, let's try it again. Different problem. So again, we'll do this one first, f of negative 2. So f of x is x cubed. So f of negative 2, well, we're just plugging in a negative 2 for x. So it is negative 2 to the third power. So you grab a calculator, negative 2 to the third power is going to be negative 8. So that's it. That's all you do there. Okay. Now for the other one, we've got f inverse of 27. Again, that's a completely separate problem that has nothing to do with the first one we just solved. We have f inverse of 27. So we still start here. F of x equals x cubed, but the 27 does not go in for x, it goes in for f of x. So you replace this f of x with 27. So 27 equals x cubed. Now, then you have to solve, whoa, how'd that erase? Then you have to solve 27 equals x cubed. Now, how do you do that? Well, you're going to have to do a cube root. So you have x cubed equals 27, and what you're going to do is cube root, and then this will be x. And on the left side, you'll have cube root 27, and you'll need to know how to calculate that on a calculator or by hand or on a website like Wolfram Alpha. So let's go Wolfram Alpha. Maybe? Okay. Oh, yeah, this is what we were doing last. So you would be able to, you can do a cube root two different ways. You can either type cube RT 27. That's one way to do it on Wolfram. And it will tell you 3. 3 is the answer. Or you can actually do it as a 1/3 power. So you can do 27 exponent 1/3. That's another way to do a cube root. You can already see that it's telling me the answer is 3 again, but I'll hit enter. Exact result 3. Or you could even have, we could have just typed in the problem. We could have said 27 equals x to the 3. That's how it was one line before. 27 equals x to the 3, and it will solve it for you and give you real solution x equals 3. Okay, so you can use a computer to help with these if you need to. Let's go back to notes. All right, here's a couple more things involving numbers. This is basically the same as a table. Let's see what it says. F of x is some invertible function. That means f has an inverse. And 7, 5 and 4, 2 are points on y equals f of x. Find the following. And again, this is just trying to reinforce the point that we're looking at x and y values. So this is an x because it's an f. This is a y or f of x value because it's on f inverse. This is also a y or f of x value. And the last one, f of 7, that's an x. And so whatever the other one is what we're looking for. So when this says x equals 4, you find x equals 4 right there, and then the answer will be the y value, 2. And here you have f inverse of 5. That's a y equals 5. So you look at your points, find y equals 5. There it is, y equals 5. And then the answer will be the other value, so the x, which is 7. F inverse of 2, so we're looking for y equals 2. There's y equals 2. So the answer will be 4. And finally, f of 7, that's x equals 7. That's right there. So the other value is a 5. So our answer will be 5. Okay. And so that's how you get started with these. That's how you get started calculating things with inverse functions. Okay, so that's going to be mostly it for this first video. Let me back out and look at the notes here. So the next thing that we're going to look at, but we'll do it in the next video, is going to be finding an inverse function, you know, from an f, right? They give you an f, they want the f inverse. That's what they want. Okay, and there's going to be some steps, and we just follow these same steps every time, but it's a little bit more lengthy, I should say. The calculations are a little bit longer, and so we'll save it for another video. All right, so that's going to be it for now. Thanks for watching. Good luck with the homework, and let me know if you have any questions.